You know how some people say that they live in the middle of nowhere, and you never really quite believe them? Well, I'm going to say the exact same thing, but it's true. And here's my proof. This is the view from my front porch, and that house on the left-hand side is my closest neighbor living at a half a mile away. Hi, my name's Stacy Arner. I'm the third generation of my family to grow up on our livestock farm in western Pennsylvania in Butler County, a county predominant for its large number of family-owned generational farms just like mine. However, in recent years, all that has begun to give way to the rising oil and natural gas companies, who are willing to pay an arm and a leg in order to get as much land as possible to harvest Marcellus shale natural gas. Although natural gas is supposed to be the fuel to bridge the energy transition from fossil fuels to renewable energy sources, the Natural Gas Watch states that up to 4% of natural gas leaks undetected into our atmosphere as methane, negating most, if not all, of the benefits of natural gas. Being a chemical engineering student with a special interest in energy and fuels, and being a farm girl living in an area of rapidly expanding Marcellus shale natural gas production, I decided to look into different methane gas detection technologies. And I have found that infrared cameras are not only effective at detecting methane gas leaks, but also decrease the overall time it takes to locate and repair these leaks as compared to the current methane gas detection technologies. In my presentation today, I would like to discuss what exactly methane gas is and how dangerous it is to our environment, how infrared cameras work and why they are more effective than the current methane gas detection technologies, and finally, what exactly the methane mitigation industry is and how infrared cameras can be implemented within this industry. So let's begin by talking about what exactly methane gas is. Methane is an odorless, colorless, and flammable greenhouse gas. It is the main component of natural gas and is responsible for all of natural gas's greenhouse gas effects. Methane can be produced as a byproduct of natural processes, such as through the decay of organic matter or through the digestive cycles of cows, sheep, and goats, or it can be produced as a byproduct of human interactions, predominantly through that of the energy industry. According to the Energy Information Administration's U.S. greenhouse gas emissions by gas chart that you see here, methane is the second largest contributor to the greenhouse gas emissions in the United States. In 2009, methane made up 11.1% of the total emissions. This number might seem really small, especially compared to the energy-related carbon dioxide's 81.5%, but the fact of the matter is, methane gas is over 21 times more harmful to our environment than carbon dioxide. So that means for every 1 pound of methane we're releasing into the atmosphere, we're releasing at least 21 pounds of carbon dioxide. So, if methane gas is so dangerous, then why aren't we doing anything about it? Well, like I had said earlier, methane is both odorless and colorless, so it's completely undetectable to the human senses. However, just like any other gas, methane absorbs light at a specific wavelength and frequency. This wavelength and frequency lies outside of the visible color spectrum in the infrared spectrum. Infrared cameras work by taking an infrared picture and then converting that picture into a grayscale image that allows us to see the colorless gases. Infrared cameras are equipped to take both still pictures and videos, which allows for real-time detection of methane gas leaks. On top of that, many infrared cameras are integrated with GPS technology, which allows for the operator of the camera to pinpoint the exact location of a methane gas leak on screen before sending somebody out into the field to fix it. This picture here is of 2 petroleum storage tanks. This picture was taken by the Clean Air Task Force with a regular point-and-shoot camera. If we were to go out into the field today, this is probably very much the same image that we would see. However, this picture is of the exact same petroleum storage tanks. But as you can see, there are 2 black plumes of smoke. An infrared camera was used to take this picture, and it clearly visualizes where the methane gas leaks are coming from the petroleum storage tanks. Unfortunately, infrared cameras are not able to calculate the overall concentration of methane gas, which is something that the current methane gas detectors can do. The methane gas detector seen here is usually what we use in the energy industry as of right now.
These are called sniffers, and they work by taking a sample of the air, counting the number of methane gas particles in that sample, and then determining the overall concentration of methane gas. However, there are several issues to using these methane gas detectors. For one, they are unable to differentiate between the methane gas produced by the energy industry and the methane gas produced by natural processes. And because a lot of natural gas infrastructure is located in rural areas, this can cause for a lot of false alarms of methane gas leaks. On top of that, these detectors are unable to show you exactly where the methane gas leak is occurring at. So the operator of the detector must pretty much do a point and shoot method until they find the highest area of methane gas concentration, and then just assume that that's where the methane gas leak is at. Infrared cameras are able to make up for these differences because they show a clear image of exactly where the methane gas leak is at. As a result, it allows for a faster location and repair time of methane gas leaks. Infrared cameras can be implemented within the energy industry through what the Environmental Defense Fund refers to as the methane mitigation industry. The methane mitigation industry is composed of companies that provide leak detection and repair services, or LDAR services. LDAR companies are typically subcontracted by larger oil and natural gas companies to complete routine checks and maintenance on natural gas infrastructure. LDAR companies use methane gas detectors by either having somebody walk around natural gas infrastructure or by flying helicopters above the structures to spot methane gas leaks. Infrared cameras can be implemented within the methane mitigation industry in the exact same way that the current methane gas detectors that we use today can be. One drawback, though, to using the helicopters for LDAR services is the fact that they are extremely expensive. According to an article in the Pittsburgh Post-Gazette about the LDAR service industry in Pittsburgh, the cost of using a helicopter for LDAR services is approximately $2,000 per hour. That is extremely expensive, but luckily there may be a solution in sight, and that is due to drones like the ones seen here. Drones can fly for an hour and a half on as little as $3 worth of gasoline. As of right now, though, the Federal Aviation Administration currently has a ban placed on the commercial usage of drones, but that legislation is up for review by the end of 2015, so we may be able to see infrared cameras attached to drones flying above natural gas infrastructures in the very near future. In my presentation today, I've discussed what exactly methane gas is and how dangerous it is to our environment as compared to carbon dioxide. I have also discussed how infrared cameras work and why they are more effective than the current methane gas detectors. Finally, I discussed what exactly the methane mitigation industry is and how infrared cameras can be implemented within this industry. By implementing the widespread usage of methane gas detectors in the energy industry, we can decrease the overall amount of methane gas emissions and make natural gas the viable energy source that we need it to be in order to help us transition from fossil fuels to renewable energy sources. Thank you.